Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Jest, Tifr, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 25 of mathematical physics, in which we are going to study residue of complex function. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start. So, residue of complex function. Okay, residue of residue of residue of a complex function. Complex function. So, residue of a complex function. Okay. So, there are different methods by which we can get a residue of a complex function. Okay. Number first is residue at z equal to a, if we have to find. So that is going to be limit z test to a. Okay, limit z test to a limit z test to a z minus a fz. Okay, so fz is a complex function. Okay, fz is a complex function. Fz is complex function. Okay, so for residue, we have to find residue at z equal to a. So that how we are going to find it? That is equal to limit z test to a limit z test to a z minus a fz. Okay, second method is, I'll solve examples, then it will clear your doubt. Okay, so second is if we have given function that is fz equal to phi z upon psi z. Okay, this is we have to given, and if uh, phi a psi a equal to 0. Okay, this if you put in this function psi z, if you put z equal to a, and then this is giving psi a equal to 0, right? And but phi a not equal to 0, but phi a is not equal to 0, right? This function, if putting z equal to a, not giving a 0 value. So in that case, how we are going to find the residue? So residue at z equal to a is going to be phi a upon psi dash a. Okay, so what we do is, if this would be the condition, then we will differentiate the denominator, that is psi z. Okay, and we'll put z equal to a, right? So residue at z equal to a is going to be phi a upon psi dash a. Okay, this is psi dash a, psi dash a. Okay, this is the second way. Third is residue of a pole of order n. Okay, so we have to find out the residue of a pole whose order is a. Okay, or sorry, order is n, order n. Okay, for example, like for this, so this is going to be residue at z equal to a. So we are going to find residue of a pole whose order is n. Okay, of order a, order n. Okay, So that is going to be very important formula. Residue at z equal to a is going to be 1 upon n minus 1 factorial 1 upon n minus 1 factorial dn minus 1 and dzn minus 1 dz at n minus 1 and then z minus a to the power n, okay, and fz. Okay, so this is the formula, very important one, guys. Okay, you need to note down this one. So this is residue at z equal to a equal to 1 upon n minus 1 factorial dn minus 1 upon dzn minus 1 z minus a to the power n fz. Okay, n is the order of the pole. Okay, next is fourth point. We can also, if we can also find, if we have given the infinite series, also we can find the residue like this. Okay, suppose at z equal to a, so we can say z minus a equal to, will put, since we have to find the pole at z equal to a, right? Residue at z equal to a. Okay, z equal to a is given. So so what we'll do is we'll put z minus a, will take this side, equal to t. Okay, z minus a equal to t, so it means value of z is going to be t plus a, and we'll put the value in expression. Okay, and then coefficient of 1 upon t is going to be, okay, so coefficient of 1 upon t is going to be the residue at z equal to a, residue at z equal to a. Okay, so what we are going to do is we'll put z minus a, we'll put z minus a equal to t. We consider z minus a equal to t, then value of z is going to be t plus a. We'll put the value of z, and then the coefficient of t, coefficient of 1 upon t is going to be the residue at z equal to a. Okay, I will solve question, okay, and then it will be more clearer to you. Okay, so now I'm going to solve questions. Okay, then you will understand it. Okay, so the first question I'm going to start. The first question is, meanwhile just let me check whether I'm audible or not. Residue at, yes, I'm audible. So question number 1 is, this is fz equal to, we have been given fz equal to 1 minus z upon z into z minus 1 into z minus 2. Okay, this is the complex function is given fz. Okay, and we have to and so we have to find the residue. Okay, so first, for getting pole, right, we'll put denominator equal to zeros. Okay, so for pole, okay, here we'll put this, and then we'll expand the series. Okay, I'll tell you, I'll give example. So I'll solve question, then it will clear your doubt. Okay, so we'll put this expression z equal to t plus a, then we'll expand it, and after that coefficient of t is going to be residue at z equal to a. Okay, so this is the one. So for poles, z into z minus 1 into z minus 2 is going to be equal to 0. For pole, what we'll do is we'll put denominator equal to 0 for poles, and then we'll find the value of z. So equal to 0, right? So z value of z are, poles are, okay, z equal to 0. So poles are going to be z equal to 0, 1 and 2. So these are the poles. Okay, right. So now we'll find the residue. Okay, so residue at z equal to 0, it is going to be this first one. Okay, limit z minus a, z tends to a, z minus a fz. Okay, so this is going to be limit z tends to 0, z minus 0 into 1 minus z upon z into z minus 1, z minus 2. Okay, so this is the one. So z will get cancelled. Okay, and now we'll put z equal to 0. So this is going to be 1 minus 0 upon 0 minus 1 into 0 minus 2. Okay, and this value is going to be 1 upon 2. Okay, this is the one. Now at z equal to 1, residue at z equal to 1 is going to be limit z tends to 1, z minus 1 into this one, 1 minus z. I think this is 1 minus z, right? So this is 0, 1 minus z. Yeah, that's correct. So 1 minus z, 1 minus z. I think we have done some mistake here. Okay, here we can solve it further. Okay, because numerator and denominator are equal. There is some mistake we have done. I'll rectify it. Okay guys, just wait, it's done. Okay, so here this is going to get cancelled, guys. Okay, this will cancel by minus 1 time, right? So fz is going to be minus 1 upon z into z minus 2. Okay, so this is the function fz. Okay, so now we can easily so for residue, z into z minus 2 is going to be 0, so poles are going to be z equal to 0 and z equal to 2. So now for residue at z equal to 0 is going to be limit z tends to 0, z minus 0 into fz 1 upon z minus 1 upon z into z minus 1. Okay, z will get cancelled and we'll put z equal to 0, so it is 1 minus 0 minus 1, that is 1. So residue at z equal to 0 is 1. Okay, here we have done it's, yeah, this is z minus 2, guys, z minus 2, and this is going to be 0 minus 2. Okay, this will get cancelled, 0 minus 2, and this value is going to be minus minus plus 1 by 2. Okay, so residue at z equal to 0 is 1 by 2, guys, 1 by 2. Now similarly, residue at z equal to 2 will find 2, so this is going to be z minus 2 into minus 1 upon z into z minus 2. Z minus 2 will get cancelled, we'll put z equal to 2, so this is 2, that is minus 1 by 2. Okay, so residue at z equal to 2 is minus 1 by 2. Okay, residue at z equal to 2 is minus 1 by 2. Well, so this is the residue. Now next question we are going to solve. Next question are question 2. This question is fz function is given, fz equal to z square into e to the power 1 minus z. Okay, so how we are going to solve it? So we'll expand e to the power 1 upon z. Okay, so this is going to be 1 plus 1 upon z, 1 plus 1 upon z plus 1 by 2 factorial z square plus 1 by 3 factorial z cube plus so on. Okay, so now we'll multiply this with this, so this is going to be z square upon z plus 1 upon 2 plus 1 upon 3 factorial z plus so on, right? Okay, so this is the value, and now we'll find, and pole is z equal to 0, right? At 0 this value is going to be, fz is going to be infinity, right? So because the pole is z equal to 0, so residue for this residue at z equal to 0 is going to be coefficient of 1 upon z. Okay, coefficient of 1 upon z, coefficient of 1 upon z, and this is coefficient of 1 upon z is 3 factorial. 3 factorial, it means 3 into 2 into 1, that is 1 by 6. Okay, so 1 by 6 is the answer, guys. Very simple. Next question. Next question is fz, the function fz is given z square e to the power 1 minus z square e to the power 1 upon z minus 1, 1 upon z minus 1. Okay, so this is the function, and so we'll solve it. So this is going to be z square, will expand it. Okay, so this is going to be 1 plus 1 upon z minus 1 plus 1 upon 2 factorial z minus 1 whole square, right? We know how to open e to the power x, right? And plus 1 upon 3 factorial z minus 1 to the power 3 plus so on. Okay, so this is the one. Now we have to find it. So what we are going to make substitutions. We'll take z minus 1 equal to t. Okay, let's suppose z minus 1 equal to t, so it means value of z is going to be t plus 1. We'll put the value of z here, so this is going to be z square, that is z square means t plus 1 whole square into 1 plus 1 upon z minus 1 equal to t, right? T plus 1 upon 2 factorial t square plus 1 upon 3 factorial t cube plus so on. Okay, so this is going to be this value is going to be z is going to be, we'll open it. Okay, t plus 1, so it is going to be t square, t plus 1 whole square equal to t square plus 2t plus 1, right? And this value is going to be 1 plus 1 upon t plus 1 plus 1 upon t plus 1 upon 2 factorial t square plus 1 upon 3 factorial t cube plus so on. Okay, so this is going to be, now we'll multiply it. Okay, because the coefficient of 1 upon t is going to be the residue at z equal to 1, right? This one is z equal to 1. Okay, so this is going to be, we'll multiply it, so it is going to be, there would be three series, right? The first one t square plus t plus 1 upon 2 factorial plus 1 upon 3 factorial t, this plus so on, this is one term. Okay, plus I will multiply this with 2t, this is going to be 2t plus this is going to be 2 plus 1 upon 2 factorial t plus so on. Okay, we need just the coefficient of 1 upon t. Okay, this is 2t, this is 1 upon t, right? Third, we'll multiply this with this, so this is going to be plus 1 plus 1 upon t plus 1 upon 2t square 1 upon 2 factorial t square plus so on. Okay, so this is going to be now this from here, the coefficient of t is going to be coefficient of 1 upon t, coefficient of 1 upon t is going to be this one, guys. So in this expression, the coefficient of 1 upon t is 1 upon 3 factorial plus here 1 upon 2 factorial plus here it is 1. We'll add it, so this is going to be 1 upon 6, 3 factorial value is 6, 1 upon 2 plus 1, right? So this value is going to be 13 by 12. Okay, 13 by 6, my apology, 13 by 6. 13 by 6. Okay, this is the answer, 13 by 6. So residue of this, okay, 1 upon t or coefficient of 1 upon t, or we can say coefficient of 1 upon z minus 1, right? Because z minus 1 equal to t. So this answer is this is the 13.6 is the answer. Sorry, my apology, this is 13 upon 6 is the answer. Okay, next point. Next point is this is Cauchy residue theorem. Okay, Cauchy residue theorem. Cauchy residue theorem. Okay, Cauchy residue theorem, which we are going to discuss now. Okay, the first point is, if the function fz, if the function fz is analytic, if the function fz is analytic everywhere, inside the contour C. Okay, if function fz is analytic everywhere, okay, inside the contour C, then closed contour integration fz dz, okay, is value of fz dz equal to 0. If there are no poles, it means the value of closed contour integration fz dz is 0. Very important, okay, this is 0. This is the first point. Next is for all poles, if there are poles, okay, for all the poles inside the contour, poles inside the contour, all the poles inside the contour, all the poles inside the contour C, okay, so there are poles inside the contour C. If that is the case, the function is not analytic everywhere inside the contour, right? So there are some poles inside the contour C. In that case, the integration contour, closed contour integration fz dz is going to be equal to 2 pi I into sum of residue, okay, 2 pi I into sum of residue, okay. So this is the second point. If there are poles inside the contour, then the closed contour integration of the function fz is going to be equal to 2 pi I sum of residue, okay. So so whatever the poles are there, we'll find the residue at those poles, and then we'll put values in this expression, okay, 2 pi I sum of residue, and we'll get the required answer of required integration of this function, okay, or this integral, okay. So I'm going to solve the question, okay, then questions are going to clear your all doubts, okay. So question, this is closed contour integration e to the power z dz, okay, you need to find out, and contour is given, contour is z mod z equal to 1. Mod z equal to 1 means this is mod z equal to 1, okay. So this means we can write mod z means mod z minus 0 equal to 1, okay. So mod z equal to 1, we can also write mod z minus 0 equal to 1, okay. So this means there is a circle, contour is a circle, okay, contour is a circle whose radius is 1 and whose center is at origin, okay, 0 0, okay. So this means this is the contour, this is the circle, okay, center is 0 0, okay, and the radius is 1, okay. So now I'm going to solve it. So you can see in this expression, since fz equal to since fz value is given, that is e to the power z dz, e to the power z, right? So this is the fz given. So you can see in the function, right, if we put z equal to infinity, okay, if z in this function, if z tends to infinity, right, in that case function fz is going to be infinity, right? In that case function will be infinity, right? And here we can see that, right, at z equal to infinity this value is going to be infinity, right? In other values it is not going to be infinity, right? So here you can see radius is 1 and this value is giving infinity, right, at z tends to infinity, right? So this is a contour, this is a circle of unit radius, right? It means this means the function fz is analytical uh, inside the contour, okay. So it means it means the integration of this is going to be 0. Okay, so just give me 1 second. Okay, so function now this means the function fz is analytic everywhere inside the contour C. Okay, yeah, right. Since fz equal to ez is analytic everywhere inside the contour, okay, inside the contour, it means this implies integral. We'll use first Cauchy theorem, right? This is the first one. Integration of fz is going to be 0. So closed contour integration e to the power z dz is going to be 0. Okay, so this is the answer. Very simple, because if they would be pole, then that would have been different case. Okay, we'll do that as well. So in this case, because the function is analytic everywhere inside the contour, right? So it means this function is the value of this function is 0. Okay, next question. Next question is fz equal to this is z square upon z minus 1 and z minus 2. Okay, so this is the function, okay, given, and the contour is given. Contour is z minus 1 mod z minus 1 equal to 2. Okay, so this is 2. Okay, so since contour is given, so this is contour mod z minus 1 equal to 2 means there is a circle, this mean, okay, and whose radius is 2 and whose center is at z equal to 1. So there is a center that z equal to 1. Okay, and z equal to 1, this is the center, right? So this is going to be circle, guys. Okay, it is not looking like circle, but it is a circle. Consider this circle. Okay, so this is the center, of circle. Wait, guys, it is not. This is the circle, guys. Okay, consider this circle. This radius is 2. This is center at x at z equal to 1. Okay, at z equal to 1, and this radius is 2, guys. Okay, this radius is 2. Okay, so now we'll solve it. Radius 2. Okay, so poles are going to be z minus 1 equal to z minus 1 and z minus 2 equal to 0. So poles are going to be z equal to 1 and 2. Okay, so here we can see z equal to 1 means this will be inside like here, right, 1, and z equal to 2 means it will be on the line of contour, right? So it means both poles 1 and 2, both poles lies in the contour. So z equal to 1 lies in the contour, and z equal to 2 is also lies in the contour because its radius is 2. So z will be that 2.2 will be somewhere here, right? So both poles 1 and 2 lies inside the contour, right? So it means we'll find the residue. Okay, So residue at z equal to 1 first. Okay, z equal to 1. This is going to be limit z tends to 1, z minus 1 into function is z square upon z minus 1, z minus 2. Okay, so z minus 1 1 will get cancelled, and this value is going to be 1 square upon 1 minus 2, right? So this is going to be minus 1. Okay, this is the residue at z equal to 1. Similarly, residue at z equal to 2 is going to be limit z tends to 2, z minus 2 into z square upon z minus 1, z minus 2. Okay, so z minus 2 will get cancelled, and z equal to 2 will put the value, so 2 square upon 2 minus 1, so this value is going to be 4. Okay, so value of residue z at z equal to 1 is minus 1, and 2 at z equal to 2 is 4, right? So from Cauchy integral theorem, the integration contour closed integration z square upon z minus 1 into z minus 2. The value of this integration dz is going to be 2 pi I by Cauchy integral theorem, right? 2 pi I into sum of residue, right? So this is 2 pi I sum of residue. Residues are z equal to 1 is at z equal to 1 is minus 1, and this is 2 at z equal to 2 is 4, right? So minus 1 plus 4. So this value is going to be 6 pi I. Okay, so this value is 6 pi I, and this is the answer. Okay guys, next question is closed contour integration 4 minus 3z upon z into z minus 1 into z minus 3, z minus 3 dz. Okay, so this is going to be closed contour integration 4 minus 3z upon z into z minus 1, z minus 3 dz. Okay, this is the one. So, and C is given, contour is given, z equal to 3 by 2. Okay, so z equal to 3 by 2 means the circle whose center is at origin. Okay, so I'm going to solve it since given, right? Mod z equal to 3 by 2. It means z minus 0 mod equal to 3 by 2, right? So there's a circle. The contour is a circle whose center is at origin and radius is 3 by 2, right? So we'll draw the contour first. So this is the contour, okay, and this is circle, guys. Okay, it is not looking the circle, but it is a circle. Consider it. Okay, it is not exactly looking the circle. Let me this one. Okay, so this is 0 0 and this is 3 by 2. Okay, so now we have a function. Okay, we'll find the pole. So poles is going to be poles means this denominator is going to be 0. So z, this is z into z minus 1. Okay, this is going to be z into z minus 1 into z minus 2. Z minus 2 is going to be 0. This implies z equal to 0, 1 and 2. These are the values. Now we'll check the poles which lies inside the contour. Okay, so the radius is 3 by 2 means 1.4, 1.5, right? The radius is 1.5. So it means the z equal to 0 and z equal to 1 lies inside the pole, 2 doesn't lies inside the pole. So we will just consider the poles which lies inside the contour. So it means only these two values considered. So residue, will find residue only on those poles which lies inside the contour. Okay, so the residue at z equal to 0 is going to be limit that is limit z s to infinity, okay, and z minus 0 into the value is z square upon z into z minus 1 into z minus, this value is z minus 3 or 2, it's 3 guys, I made a mistake, this is 3 guys, okay, 3 actually. So this is z into z minus 3, so this is going to be like, this is 3 and this is 3. So 3 doesn't lie inside, the 3 doesn't lies inside the contour, so we'll not consider that. So this is z minus 3, okay. So z will get cancelled and this value is going to be z tends to 0. So this value is going to be 0 guys. What mistake we have? Okay, we have written the wrong question. Yes, so this is 4 minus 3z, okay. 4 minus 3z, this is the value guys, okay, this one, 4 minus 3z, 4 minus 3z. Okay, 4 minus 3z. So we'll put the value. So this is going to be 4 minus 0 upon z equal to 0, right? 0 minus 1 and so this is going to be 4 by 3. Okay, now we'll find residue. We'll find residue at z equal to 1. Okay, so this is going to be limit z tends to 1 z minus 1 into 4 minus 3z upon z into z minus 1 and z minus 3. Z minus 1 will get cancelled and we'll put z equal to 1. So 4 minus 3 into 1 upon, this is going to be 1 into 1 minus 3. Okay. So this value is going to be, this is 1 upon minus 3. So minus 1 by 3. Okay. My apologies. So minus 1 by 2. Because if we subtract 3 from 1, so this is going to be minus 2. Minus 1 by 2. Okay. So it means the value of the integration is going to be closed contour integration 4z minus 3 upon z into z minus 1 into z minus 3. Okay, this value is going to be 2 pi I sum of residue, right? Sum of residue. So means 2 pi I residues are this is 1 4 by 3 first at 0, residue at 0, residue at z equal to 0, and residue at z equal to 1. So 4 by 3 plus minus 1 by 2. Okay, so this is going to be 4 by 3 minus 1 by 2. So we'll solve it, and this is going to be 5 pi I upon 3. Okay, 5 pi I upon 3. So this is the answer, 5 pi I upon 3. Okay, well, this is the one. Next question, guys. Next question is closed contour integration sin z upon z to the power 6 dz. Okay, this is also a good question. So I will solve it by two methods. Okay, first method, three methods actually. So first method is this one, right? So what we are going to do is, this is very good question, guys. Okay, so we'll find pole. For pole, this is you need to find, right? Pole z to the power 6 equal to 0 implies z equal to 0. Okay, pole is z equal to 0 of order 6. Okay, so z to the power 6 equal to 0 implies z equal to 0. So this is a pole of order 6. Okay, so we know residue at z equal to 0 is going to be, so order pole we know, right? This is 1 upon, I have already explained, 1 upon n minus 1 factorial dn minus 1 dzn minus 1 then z minus a into fz, right? This is the formula. So that is residue at z equal to a for the for order of pole, right? If there is a pole of some order, this we know, right? So it means residue at z equal to 0 is going to be 1 upon, this is the order of 6, right? So 6 minus 1 factorial, 6 minus 1 factorial d5, 6 minus 1 d5 upon dz5, dz to the power 5, z minus 0, this is to the power 6, guys. Okay, and this power 6 fz is sin z upon z6, right? This one. So z6 and z6, this is going to be will get cancelled. So this is going to be 1 upon 5 factorial, and this is d5 upon dz5 sin z. So we will differentiate this sin z 5 times. Okay, so this is going to be, this is a limit as well. Okay, limit. This is at z equal to 0, at z equal to 0. Okay, so this is going to be okay. So 1 upon residue at z equal to 0 is going to be 1 upon 5 factorial. So we'll differentiate it, right? First time it is going to be sin z cos, right? Second time sin, this will be minus, right? And then third time cos, fourth time sin, fifth times cos, right? So this value is going to be cos z at z equal to 0, and cos 0 value we know, right? Cos 0 value we know. So this is going to be, cos 0 value is 1, right? So 1 upon 5 factorial into cos 0, and this is 1 upon 5 factorial, and value of 1 upon 5 factorial is 120. Okay, so this is the answer. This is the residue, right? So this is the residue, guys. So now this means this one, integration sin z, closed contour integration sin z upon z to the power 6 dz, right? This value is going to be 2 pi I into sum of residue, right? So this is going to be 2 pi I into 120, and this is going to be pi I upon 60. This is the answer. Okay. Second method also I'm going to solve it by second method. Second method is going to be second method. Second method is this one. So we have been given fz, that is sin z on z to the power 6, right? So what we are going to do is we'll expand it. Okay, 1 upon z to the power 6 we know, and sin z will open it. So this is going to be z minus z cube upon 3 factorial plus z to the power 5 upon 5 factorial plus so on. Okay, so this is going to be z will multiply z to the power 1 upon z to the power 6 with we'll take this inside. So this is going to be 1 upon z to the power 5 minus 1 upon 3 factorial z cube plus this is going to be 1 upon 5 factorial into z plus so on, right? And residue we know. Residue means residue at z equal to 0, that is going to be coefficient of coefficient of 1 upon z, right? So this is going to be, that is 1 upon 5 factorial means 1 upon 1 upon 120, right? So it means, this means closed contour integration sin z upon z to the power 6, this value is going to be z. This value is going to be, this value is going to be 2 pi I sigma residue, sum of residue, that's 2 pi I into 120, and this value is going to be pi I upon 60, right? In this way also you can find out. So there is two method I told you to solve this question, and third method is also there, guys, which I'm also going, third method. Okay, order of pole we know that is 6, right? So this is going to be third. In third method we can write limit z tends to 0 and z minus 0 to the power, we can write 5, okay, and sin z upon z to the power 6. Okay, so from here what we can do, this is z5 will get cancelled, right? So limit z tends to 0 and sin z upon z it will get cancelled, and this value is 1. So it means so here this is not a third method actually. So this is we can find the order of the pole. Okay, so order of the pole is going to be, so this means order of, because this is 1 means limit exists, right? Exists means order of the pole is 6. order of pole is 6. Okay, sorry, order of pole is 5. We can find like this. This is order of pole as well. Okay, we have this function for finding order of pole. We'll do like this. Okay, so because z to the power 5, we know this value limit z tends to 0. I have already explained in my previous lecture. Sin z upon z, this value is 1. Okay, so the order of this function is order of pole is 5 from here. Okay, so these are two methods, right? The first one is like this. This means you can just use the formula and find out. Second is you have just opened the sin z, and then you have found the coefficient of 1 upon z that as a residue, and then you used Cauchy residue theorem, theorem, right, integral theorem, to find the value of the integral. Okay, yeah. Next question, guys. Next is so this is also a good question. Question is integration, closed contour integration sin z upon 2z minus pi, sin z upon 2z minus pi dz. Okay, so this you need to find. So closed contour integration sin z upon 2z minus pi, okay, dz you need to find out, and contour is given mod z equal to 2. It means the contour is a circle of radius 2 whose center is at origin, right? So we'll draw the circle. This is the circle. Okay, this is the circle, guys. Okay, whose radius is 2. Okay, and now we have to find the value of this. Okay, so how we are going to solve this, that I'm telling you. First we will find pole. For pole, the denominator is going to be equal to 0. So it means 2z equal to pi implies value of z equal to pi by 2. Okay, so now we'll find the limit, and pi by 2 is inside the contour, guys. How? Because value of pi is 3.14, right, and half of that is less than 2. So this is inside the contour, means we'll find the residue. So residue at z equal to pi by 2 is going to be limit, we know, limit z tends to pi by 2, and that is 2z. Okay, this is z minus, this is going to be z minus pi by 2 into sin z upon 2z minus pi, right, this one. So we'll solve it further. So this we can write limit z tends to pi by 2, z tends to pi by 2, and this is going to be z minus pi by 2 sin z, and this value is going to, this we can write like this. Okay, we can like this. This one, right, we can take LCM 2, and this is going to be 2z minus pi, we can write. Okay, 2 LCM and then 2z minus pi upon 2. This we can write like this, and this is 2z. Very good question, guys. Okay, two z minus pi. Okay, so this will get cancelled, and this sign, this is 2. This is 2, right? So this is going to be 1 upon 2, then sin z is value of sin z, sin pi by 2, right? Sin pi by 2 will put the value of z pi by 2 by 2. This is pi by, sin pi by 2 is 1, so this is 1 by 2. 1 by 2. Okay, 1 by 2. So this means the value of this integration is going to be I is going to be 2 pi I into sum of residue, and this is going to be 2 pi I. Sum of residue means this one value, this is 1 by 2, 1 by 2. So this value is going to be pi I. Pi I. This is the answer, guys. Okay. Now there is one type of question. Okay. This we can easily solve by trick, and which was asked in NET exam as well. Okay. Very good question. So I'm going to solve this question by trick. So before that, before solving this question, I'm going to tell you the trick. Okay. Trick. Trick is if we have a function like this 0 to 2 pi form, integration 0 to 2 pi, and d theta upon a plus b cos theta. Okay, if function is in this form, okay, d theta upon a plus b cos theta, right? If function is in this form where a is greater than b, okay, and b is greater than 0, if this is the form, okay, this if question is in this form, then how to solve it? I'll give example. For example, this one 0 to 2 pi, okay, d theta upon 5 plus 4 cos theta. Okay, this question we have to solve it. So there's a trick for this. First let me write down the trick. Trick is if this is in this form, so the solution of this is going to be 2 pi upon root a square minus b square. Okay, this is the solution. Okay, if this is formed, then its solution is going to be 2 pi upon root a square minus b square. Now I'll give example. Example is we have a question 0 to 2 pi, okay, d theta upon 5 plus 4 cos theta. Okay, this is the question. So how we are going to solve this? Very simple. So 2 pi upon a and b are 5, 4, and clearly 5 is greater than 4 and 4 is greater than 0. So this is going to be 5 square 5 square. This is the one, okay. 5 square minus 4 square, and this value is going to be 2 pi upon root 9, that is 2 pi by 3. Okay, this is the answer. Okay, so one question is asked in this CSIR net that I'm going to solve. That question is, which is asked in CSIR net December 2018. Okay, and the question is you need to find the value of 0 to pi d theta upon 5 plus 4 cos theta. Okay, this is the we need to find out this value. Okay, so we can see this is even function, guys. Cos theta is cos theta value is always positive, right? So it's a even function. So and we know this formula, but limit should be 0 to 2 pi, right? The same question, but here you can see limit is not 0 to 2 pi, limit is 0 to 2 pi. So because it's a even function, right? Even function, so it means we can change the limit, right? We can we can break the limit, right? So 0 to pi d theta upon 5 plus 4 cos theta. This value is this we can write 1 by 2 0 to 2 pi, right? We can write limit like this, right? So we have increase the limit, right? So we have divided by 1 by 2. We can do it because it's a given function. Okay, so this is going to be d theta upon 5 plus 4 cos theta. Now this is in this form, right? 0 to 2 pi d theta a plus b cos theta, and this trick we know, 2 pi upon root a square minus b square. So this value is going to be root 2 pi upon the root, so this is going to be 1 upon 2 into 2 pi upon the root 5 square minus 4 square, right? And so this is going to be 1 of 5 by 2 will get cancelled, 5 upon 3. Okay, so this is the answer, guys. Very simple, and you have solved because you know the trick. That's why you have solved this question within a minute, right? Okay. If you solve it with proper method, it is going to take a lot of time. Okay. Well, guys, I'll stop here now, and before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay. Okay, guys. Remaining we are going to do in the next lecture. Okay. Okay, guys. Thank you so much. Bye now.